Hi everyone. So here's a quick demo to show you the nature of the third law, Newton's third law. We have these little cars with sensors, force sensors on them. Right? If you press that, it measures how much force is being exerted on this cart. And this one measures how much force is being exerted on this cart in the opposite direction. And that's represented on the screen, as you just saw. Okay, now what I'd like to do is I'd like to investigate the whole claim, the whole sort of parable of the bug and the windshield. Which one experiences the greater force when a 4,000-pound car is going 60 miles an hour and hits a bug, right? And what happens to the bug and what happens to the car are very different stories. But which one experiences the greater force? Well, let's take a look. Okay, so first we're going to look at these cars being of equal mass when they collide. So I'll get the sensors clicking, and there they go. Here's a collision of two cars. Equal and opposite. Okay. Now let's change the weight of one of the cars. Right? So I'll put nearly a half a kilogram more on this one. Right. Hopefully the weights will stay on during the collision. But what happens if a big car hits a slow-moving object, or an object with less mass? Which one experiences the bigger force? Well, let's investigate by looking at the graphs. The data is being collected. Here we go. Two cars of very different masses hitting each other. And there's the result. Forces occur in pairs. For every action force, there's an equal and opposite reaction force. There's no way around that. Okay? We'll take one more look. What if one of them is standing still and the other one's moving relatively quickly? Let's take a look. So a big heavy car hits a lighter one that's standing still. There's a double hit there because this one's cord got stuck under its wheels and stopped it, and it hit a second time. And you'll see that the forces always occur in pairs, equal and opposite forces.